This is lesson 6.2, Properties of Parallelograms. So we want to be able to use the relationships with sides and angles of parallelograms, and to use the relationships with diagonals of parallelograms. So let's begin with what is a parallelogram. So a parallelogram is a quadrilateral and both pair of opposite sides are parallel. So as you can see in this diagram, right here is parallel with this opposite side, and the top is parallel with the bottom side. Okay, so that means that segment AB and segment CD are opposite sides. So they do not share a side. So what do you think that means? Angle C and angle A are opposite angles. So we have AB is opposite of CD. We have angle C is opposite of angle A. Now the symbol for a parallelogram is a rectangle that's kind of slanted. So it's like a rectangle that's been italicized. So let's look at theorem 6.3. So if a quadrilateral is a parallelogram, so what does that mean? If it's a four-sided figure and the opposite sides are parallel to each other, then its opposite sides are congruent. So here we have, if ABCD is a parallelogram, that means that BC, segment BC, is congruent to segment AD, and segment AB is congruent to segment CD. And over here we have our congruency markers. So AB is congruent to CD, AD is congruent to BC. Okay, so another term that you need to know is consecutive angles. So consecutive angles share a side. So angle B and angle C are consecutive angles. Angle C and angle D are consecutive angles. So now let's take a look at theorem 6.4. If a quadrilateral is a parallelogram, then its consecutive angles are supplementary. Now what does supplementary mean again? That's right, 180 degrees. So if parallelogram ABCD, then we know that the measure of angle A plus the measure of angle B is equal to 180. We know that the measure of angle B plus the measure of angle C is equal to 180. We know that the measure of angle C plus the measure of angle D is equal to 180. And finally, we know that the measure of angle D plus the measure of angle A is equal to 180. Okay, now let's take a look. They want us to use this diagram of the lamp. They want to know, what is the measure of angle P in parallelogram PQRS? Well, angle S is 64, and they want to know what angle P is. So if I add angle P and angle S, what do I get? That's right, I get 180. So to find angle P, it's going to be 180 minus 64. And that gives me 116. So my answer is C. Okay, so we want to know if we can say if ABCD is a parallelogram. We want to know if we can say that angle A is congruent to angle C and angle B is congruent to angle D. So let's start with what we know. What happens when we add the measure of angle A plus the measure of angle D? Well, that equals 180, right? What happens when we add the measure of angle D plus the measure of angle C? Well, that equals 180 also. So can we make any conclusions about the measure of angle A and angle C? Well, we can say that the measure of angle A is congruent to the measure of angle C. We can either use substitution or the third angle theorem. So the measure, we looked at D, and then when we added angle A, we got 180. And then when we had D and we added angle C, it equaled 180. So the only thing that changed was A and C. So we know that A and C must be congruent. So yes, we can say that. So we would do the same thing with B and D. Okay, so now let's take a look at this one. If a quadrilateral is a parallelogram, then its diagonals bisect each other. So notice that E is this point right here in the center where they both cross. So AE is congruent to CE. BE is congruent to DE. Okay, so let's take a look at this problem. They want us to solve a system of linear equations to find the value of x and y in parallelogram KLMN. So they want to know what is KM, this big section, and what is LN, this other cross section. So let's start out with what we know. We know that x is equal to y plus 2 because the diagonals bisect into two congruent segments. The other thing I know is that y plus 10 is equal to 2x minus 8. Oh, well, they've got this set up beautifully for me. So I'm going to take this y plus 2 and I'm going to plug it in where it has x. So I have y plus 10 is equal to 2 times y plus 2 minus 8. So now I have y plus 10 is equal to 2y plus 4 minus 8. I'm going to combine 4 minus 8, so I'm going to get y plus 10 is equal to 2y minus 4. I'm going to bring this up here. Okay, so now I'm going to subtract y from both sides. And then I'm going to add 4 to both sides. So now I have, So now I have 14 is equal to y. So I know my y value is 14. I know that x is equal to 14 plus 2. So I know that x is equal to 16. And then the next thing I'll do is I will plug that in. Well, x is equal to 16. What's x times 2? Okay, so I know these two sides are congruent, LP and PN. So X is 16, so I know that LN is equal to 32. And now I need to find Y. So I'm going to use this one. 14 plus 10 is what? 24. 24 times 2 is 48. So I know that Km is equal to 48. So last one. So if we have 3 or more parallel lines cut off concurrent segments, so that means, congruent segments of one transversal, so this parallel line, and this parallel line, we see that they make congruent segments of AC and CE. I've got my little congruency marker. Then they cut congruent segments of all transversals. So here's my second transversal. So AC and CE are congruent to each other. BD and DF are congruent to each other. These are not necessarily the same. In fact, on here you can see that they are not congruent to each other, that BD is not congruent to AC. But BD is congruent to DF. Now let's take a look at this. In the figure, AE is parallel to BF and CG and DH. AB equals BC equals CD, which is equal to 2. So I know all of these are 2, and I know that EF is 2.25, and they want to find EH, which is this length. So 2.25 plus 2.25 plus 2.25, which will give me 6.75. And that's all we have.